Assalamualaikum warahmatullahi wabarakatuh. For this week, we are going to discuss two functional group, which is alkene and alcohol. And hopefully we can cover all with a carboxylic acid and also ester. And then for alkene, alkene has a molecular formula of CnH2n. So remember alkane, which is CnH2n plus 2. For alkene is CnH2n, and it has double bond. So the trait specific of alkene is that you will find this thing, the double bond in the chain. For nomenclature, if you are already getting used to alkane, this is going to be quite easy because the naming is similar. However, if you have two things between double bond and a branch, double bond will have smaller number than branch. So take a look at this one. This one, if we are basing it on alkane, you're going to calculate start from here 1, 2, 3, 4, 5, because the branch will have smaller number here. However, since this is alkene, the double bond has stronger influence rather than the branch. So you're not going to calculate from right. You're going to calculate from left. 1, 2, 3, 4. Because this one will have smaller number. If we use the blue one, the double bond will have number 1. But if we use the red one, then the double bond will have 4. At this moment, when we are using alkene, you have to ignore the fact that branch has higher number because double bond has stronger power than the branch. So we're going to use the blue one, 1, 2, 3, 4, and 5. So the naming is going to be same with alkane. The naming will be 4-methyl. And look at where the double bond is. The double bond attached to 1. So you're going to add 1 here. 1 pentene. Okay, this is the difference. Unlike alkane, when you use alkane, you use ane. But for alkene, it ends with -ene. So this is 4-methyl 1-pentene. Pentene. Now, next, moving on to this sample. Again, this one you can calculate from both ways. Because here, if you calculate from right, you have 1, 2, 3, and 4. The branch attached in number 2, double bond also attached in number 2. Then, if you move from here, 1, 2, 3, 4, you have double bond in number 2, but branch in number 3. So, in case like this, you have to use something that benefit both. Smaller number for both double bond and for the branch. So we are going to use the red part. So naming is going to be similar with the previous one. So it's going to be 3-methyl 2-butene. Okay? Don't make it from here where it's going to be 3-methyl. Oh sorry, this is 2-methyl. This is the wrong one, which is 3-methyl and 2-butene. This is following the blue numbering. So if you are following the blue numbering, it's going to be like this, which is wrong. Then you have to follow the red numbering because it's beneficial for both bond and for branch. So here are the correct one. Looks very simple. The difference is only in 2 and 3. But then if you're using this, yes, 2-butene, where the double bond is in number 2. But the methyl is in different number. Still, you have to consider that branch has smaller number. Of course, after you consider that bond has smaller number. Now, take a look at the final example. And here we're going to use red from left. 1, 2, 3, 4, 5. Again, double bond will have number 4, although branch will have number 2. If we use this one, 1, 2, 3, 4, and 5, you will have double bond in number 2 and branch in number 4. You follow the double bond. which one? This one. Okay, so the naming will be 4-methyl and 2-pentene. Okay, so this is quite simple if you already master alkane. Now let's moving on to alcohol. So, alcohol has same molecular formula which is, with alkane, CnH2n plus 2, but with additional of O, and functional group is OH. When you name them, it's going to end with anol. Unlike alkane with N with ane and pentene with ene, so alcohol will end with anol. Now this is naming. We're going to use the same rule as alkane, but this is going to be the same with alkene, where OH will be the main focus of small number. Again, we're going to use two colors here. I'm going to calculate from right. 1, 2, 3, 4. If you are using this numbering, you will have branch in number 2, and you will have functional group of alcohol in number 3. Then let's try the left one. 1, 2, 3, 4. For this one, you will have functional group in number 2 and branch in number 3. So we are going to use blue because this one, the functional group is more important than the branch. So the number will be 3-methyl 2-butanol. This numbering 2 is for where alcohol attach. Okay. And here's another sample. Okay, we're going to adjust this first. Now, another sample, you can calculate, or this is a bit tricky. I'm going to give you the main chain. Okay, do not consider OH as the main chain because OH is attached just like branch. So you have to calculate from here. 1, 2, 3, 4, 5. Do not start the calculation from here. This is not number 1. Number 1 is still where the CH is attached. This is CH2. I'm sorry. So calculation start from C after the OH. And then you do not need to calculate again from here because this is already obvious that you start from CH2 where the OH is attached. So the name will be 3-methyl 1-pentanol. Okay. What happens if you have more than one branch? Just like the previous one, alkene or alcohol, it's going to be the same. Just write down all the branch, then you follow with the functional group. So this is an example. I'm not going to give any H in here, but let's say you have here. So if you have something like that, just name, maybe I will make this into ethyl here. Okay, then the main chain will be this one, and calculation will start from here. 1, 2, 3, 4, and 5. So can you see? You have 1-methyl here and 1-ethyl here. Still, you have to follow the rules of alphabetic order. So you put here 3-ethyl, 3-methyl, and where the OH stat is number 2, 2-pentanol. So that's how you number alcohol and alkene. If this is alkene, it's going to be the same. You just put all the branches, then the functional group of alkene. Also the number of where the double bond is attached. Okay, thank you. That's for alkene and alcohol. We will continue with carboxylic acid and ester. Assalamualaikum warahmatullahi wabarakatuh.